Welcome you all. So this is Aldous Exley from the Department of EEE, Maraframe College of Engineering and Technology. So let us discuss about the construction, characteristics and mode of operation of SCR. SCR is nothing but silicon controlled rectifier. So it's a three-terminal power electronic switching device. It is made up of silicon, that is why it is called silicon controlled rectifier. It is used to make control rectifiers. It is fabricated using silicon. Main application is control rectifier, so that it is called silicon control rectifier. It's a power electronic device. It can handle huge power. Then it belongs to thyristor family. Normally, high power ratings are available in the market. Very high voltage and very high current rated ACRs are available in the market. It can, as it is made up of silicon, it can withstand very high temperature also. Then construction. It's a 4-layer device. 4 layers are there. Then 3 terminals are there. The 3 terminals are named as anode, cathode and gate. Then the layers, first P minus layer. P minus layer is not P minus layer, P layer. This P layer is heavily doped layer with a concentration of 10 power 19 per centimeter cube. Then P layer. So first one is not P minus layer, that is P plus layer. P plus layer is a heavily doped layer. Then P layer is moderately doped layer whose doping concentration is 10 power 17 per centimeter cube. Then P as well as P plus layer, P as well as P plus layer forms the terminal anode. Then thickness of P plus layer varies from 30 to 50 micrometer. Then N minus layer, it is lightly doped with a concentration of 10 power 14 per centimeter cube. The thickness of N minus layer varies from 50 to 1000 micrometer. During forward bias, it has 3 junctions, J1, J2 and J3 are the 3 junctions. During forward biased condition, junction J1 and J3 are forward biased and J2 is reverse biased. The next to P layer, that is P layer, is doped with 10 power 17 per centimeter cube. This layer forms gate. Then thickness of this P layer varies from 30 to 100 micrometer. Then last one, N plus layer, it is heavily doped with the concentration of 10 power 19 per centimeter cube. It forms the cathode of the SCR. Then characteristics of SCR. VI characteristics or static characteristics of SCR. Then mode of operation. It has 3 modes of operations: reverse blocking mode, forward blocking mode, forward conduction mode. These are the 3 modes of operation of SCR. This waveform shows the static characteristics of SCR. First, let us see the reverse blocking mode. In this reverse blocking mode, anode is connected to negative terminal of the battery and cathode is connected to positive side of the battery, and the gate is left open, so that junctions J1 and J3 are reverse biased. J1 is only forward biased. So in this reverse blocking mode, as 2 junctions are reverse biased, the SCR does not conduct. Only a very small current flows from anode to cathode. This current is called reverse leakage current. From the characteristics curve, it is observed that when the reverse voltage increases, a very small current flows. This current is called reverse leakage current. When the reverse biased voltage reaches the reverse breakdown voltage, the reverse current reaches rapidly. Then a large power dissipation takes place in the device. Junction temperature exceeds the permissible limit. If the junction temperature exceeds the permissible limit, the device may be damaged. Then forward blocking mode. In this mode, anode is positive with respect to cathode and the gate is left open so that junction J1 and J2 are J3, J1 and J3 are forward biased, J2 is reverse biased. As gate is not given any supply or pulse, SCR does not conduct. A very small current flows from anode to cathode. This current is called forward leakage current. SCR is forward biased but it does not conduct. From the characteristics curve, it is observed that when forward voltage increases when forward voltage is increased, a very small current flows. When the forward biased voltage reaches forward breakdown voltage, SCR automatically turns on. SCR goes from forward blocking mode to forward conduction mode. When the gate is applied with positive voltage in forward blocking mode, SCR can be turned on with a very low forward biased voltage. Then forward conduction mode. In this forward conduction mode, anode is positive with respect to cathode. Gate is also connected to positive supply, so that junction J1 and J3 are forward biased and J2 is reverse biased. When positive gate to cathode voltage is applied, current flows from gate to cathode. So this current adds to the forward leakage current. Hence, avalanche breakdown occurs at the junction J2 at lower anode to cathode voltage. So easily SCR comes to on state. Then these are the very important terminologies used in SCR. Holding current. Holding current is the minimum forward current to hold or to keep the SCR in on state. Then latching current. Latching current is nothing but the minimum forward current required to turn on the SCR at the time of triggering. Then let us the merits of SCR. A very small gate current is required to turn on, since SCR is a regenerative device. That is one merit. Then SCR with high voltage and high current ratings are available, so that we can use SCR in power system side as well as in heavy electrical side. Then on state losses of across SCR is low. These are the merits. Then demerits. Gate has no control once SCR is turned on. Gate is used only to turn on the device, not to turn off. That is one major merit. Then external circuits are required to turn off the SCR. If you want to turn off SCR at our desired instant, we need to connect some external circuits to make the SCR to turn off. Then operating frequencies are very low. That is why these SCRs are suitable for low frequency operations only. Then snubber circuits are required for protection of SCRs. Extra circuits are required for protecting the SCRs from switching surges as well as high voltage and high current. Then applications. SCRs are mostly used in control rectifiers, then AC regulators for lighting and heating controls, DC motor drives to drive DC motors, then large power supplies, large regulated power supplies, then electronic circuit breakers. So these are the applications of SCR. That's all. Thank you.